Okay, welcome to today's classes. We're going to start from where, this is where we ended yesterday. As you can see, this is our protein, and then within the protein is the ligand. Okay, but I think, so we are continuing from where we stopped yesterday. So, as you can see, this is our ligand, and this is our protein. Okay. Um, like I told us yesterday, we are going to, some of us, all of us are going to work with an external ligand, which is camphorol, while I am going to use the co-crystallized ligand here, okay, as mine. However, because of that, I won't go to download this naproxen, that's the co-crystallized ligand. Okay, I won't go to download that differently. I've shown us how to download it before. So I'll simply save from here and then work with this as my external library. So in that case, I will simply save this individually, having my protein and then saving this ligand individually. Okay. Okay, so what do I do? I will need to uh, click on this arrow as well. This arrow will expose everything here, right? So I want to save the ligand. Okay, let me save the protein first. So I'll simply delete the ligand by highlighting them and clicking on my delete option. The ligand is gone, so I only have the protein here. You don't delete by highlighting here. If you highlight here, it's still there. You just unhighlight it, so you have to delete it entirely. So I will now go to my okay. I will do Control Z so that I will repeat that. I say this is the ligand protein complex, right? So I want to save my protein here as a clean protein, and then save my ligand as well as a ligand a compound before the docking. Okay. To do that, I will first of all save the protein, which means I will delete the ligand and then save just the protein. So what do I do? There's an arrow here as usual. Okay, I'll hit on this arrow from where I can highlight the ligand and click on delete from my keyboard. And then what I have here is a clean protein. So I can go ahead, go to file, go to save as. Okay, and then this is now my clean protein. Okay, and then I'll save this file type as what? PDB. That's right. Okay, I think I already have that saved here. Okay, so okay, because of this one, it won't clash, so I can just hit on save. So I have my clean protein saved. Let me bring out my ligand back. Okay, you can see the ligand is back. So what do? I will need to take off protein now, right? And save ligand now. So I'll click on protein, then I will delete it. What I have here now is just ligand. So I can now go ahead and save ligand now. This I'll call it internal ligand. Okay. And then of course I'll change the file type to what? PDB. Is that alright? Then I'll click on save. This is fine. Is that okay? So I have my protein and my ligand. If I go um, to my folder, which is in downloads, this is the tutorial folder. Okay, this is what I have. Okay, and then this ligand is supposed to be naproxen. Let me save it appropriately. Naproxen is an anti-inflammatory standard drug. Okay, so if that is done, I can take off this too. Okay, Okay, let's highlight that. Okay, so this is what I'm working with now, right? So I have my protein, I have my ligand. The next thing is now to prepare our protein and ligand for molecular docking. Yeah, we move to preparation now. We just cleaned. Okay, so we haven't prepared anything yet. So to commence the preparation, we are going to use Autodoc 2. Autodoc 2 and Autodoc Vina are hosted by the same uh, institute. Okay, so you use Autodoc 2 to get the ligand and protein ready, or ligand and target ready before the docking process. So what do I do? I will simply open the Autodoc 2. It's on your um, home screen on your desktop. Okay, so I will double click on that to get it open. It will first of all load the prompt window before loading the main software. Yeah, as you can see, this will read till 100 and then that's all. However, the speed might be dependent on if you are using computer or laptop or system. Mhm. Mhm.
I'm not using, I'm using laptop. It's just that my charger is not.
Okay, okay. It's fine. So this has loaded. To tell you to register, they just say remind me later. Mhm. Yeah, you keep reminding you later like this anytime. So this is the software. Okay. In the software, you're going to see some or different types of interfaces here or options here you can work with. However, we are going to limit ourselves to the few of them that are very much important to us, okay, while we work. So the first thing we do here is to load in our protein target. Is that all right? We'll start with our protein preparation, after which we go to ligand. So you hit on file, then inside the file, you're going to find read molecule, read section, import, and all that. You are not importing, rather you are what? Reading molecule. Okay. You go to insert, you click on read molecule, and then that will take you to your folder where you can locate your protein. Okay. This place it will bring you, of course, by implication, you have to navigate to where your folder is, right? This is the local disk. So what you do, you come to this arrow here. Okay, you can see the arrow. You click on this arrow. We are on our downloads, right? So you click on your downloads, and then this will show. Our own folder is tutorial class. So I'll click on the file, and then this is what I have. The protein I've cleaned is this, isn't it? So I'll click on the protein, or you double click from your own window, and then this will open up. This is the protein. Okay, this is how it looks by default here. Is that alright? Okay, so we have loaded the protein. After loading the protein, the next thing you do, or the next preparation you do, is to edit what we call edit the protein structure. Okay, at the course of the 3D structural elucidation, there are few components of the protein that may have been lost in that process, such as some charges, okay, some hydrogen, polar hydrogen ions, okay, and all that. These two are always the major, important aspect of the protein we always take cognizance of during our preparation. So, to get that done, we have to go to our edit button. There is an edit button at the top here. Okay, you have file, 3D graphics, then you have your edit. So if I click on edit, however, before I start editing, it's always important that you color this your protein using its default color. Okay, so that you can be able to actually notice what is happening with respect to editing in the protein. I don't know if we're getting that. Yeah, you need to color it so that it will exhibit its default. As you can see, there are many colors there. You can see something like purple. Purple is not usually, purple there is for the carbon. But like we mentioned, uh, default color of carbon is usually ash, right? And so, but here we can see we have purple, although I think it's just the carbon that changed here. So by default, we have to color this. And to do that, if you come to your left wing, which is here, you discover that this is the protein we just loaded. Is that not so? So every other thing you load here, just like in Discovery Studio, we keep aligning here. And as you load it, options like this will come out here as well. Okay. So with respect to this protein now, these holes or these options here corresponds to this. Can we see that? These are the different renderings. Okay. If you look under here, can you see where my arrow is? This first one is like a dot kind of structure. It's telling you that when you highlight this, the structure of this, okay, let's see. If we highlight this now, look at what will happen to this structure. Did you see that? If you highlight, for instance, can you see this one under C, which is like a square view? If you highlight it, look at what you have here. Is that okay? But all these are not of great importance to us, so we'll return to normal this. Our one that is of interest to us here is what the color. If anywhere you see this kind of icon, what does it signify? It signifies color, right? So we simply come down to the arrow belonging to this. Is that not so? We'll come down to here. If you go and click on this one, you'll be doing another thing. If you go and click on this, you'll be doing another. So you come down to the arrow corresponding to this protein, and then you hit on the arrow. A pop-down menu will show, okay, where you have your coloring scheme. Here we are coloring by what? Atom type. Okay. As you can see, you can even color by rainbow, by uh, property, and by chain and all that. But here we just have one chain, so we just color by what? Atom type. Atom type is the different components of the protein: carbon, hydrogen, oxygen, nitrogen, sulfur, and all that. So if I click on by atom type, you'll notice something will happen to the coloration of this. Is that okay? So I'll click on what? Atom type. Did you notice anything there? You did, right? So all the carbon has turned to what? Ash. And then if you notice, you can still find some hydrogen atoms. Okay, like we already know, the ash is for the carbon, right? The blue is for what? Nitrogen. The yellow is for what? Is for sulfur, right? The red is for what? For oxygen. So if you look closely, you discover that there are some tiny, tiny whitish color. For instance, here, can you notice some whitish color here? Yeah, these are the hydrogen atoms. However, like I said, some of them are not here because because of crystallography method of elucidation, some of them were lost. So it's part of what we are going to edit now. So I can now close this. That is clear, right? So I can now go to my edit button now to start editing. So I'll click on edit, and then I will come down to charge. I've mentioned two things I always added or edited with respect to the protein: the charge and the what? The nitrogen. So in the charge, I won't be able to get this going. So in the charge now, we are what? We are computing gas figure. Is that all right? Okay. In charge, you can add Coleman charge, or you can do what? You can compute gang stager. But in this case, we are doing what? We are computing gang stager. Okay. The both performs the same purpose. Yeah. Under edit, you go to your charges, just place your arrow on charges, and then this will pop out. Is that all right? So I'll hit on what? Add compute gang stager. And then it will tell us that about what? Negative 2.03 days were added. This is a very big charge if you know what this is all about. So you have over negative 2 point charges added to this. So we just say what? Okay. Is that okay? Then we go back again to the edit. We have added charge. The remaining thing is what? The hydrogen. If I come down to hydrogen as well, I'm going to find once I place my cursor there will be a pop down menu, right? Yeah, in the pop down menu, you are going to see add, merge, and all that. We are going to what? Add. Okay. So I will do that by hitting on what? Add. So if I hit on add now, this will pop out. Alright? This will pop out. This will ask me if I'm adding all the hydrogen or I'm adding other hydrogen to this. Is that alright? So we are not adding all hydrogen. If you add all now, the whole structure will not be jam-packed with hydrogen atoms. So we do what? We are adding polar. So I will select polar. If you're observant enough, if you hit on this OK, um, some atoms are going to be added here. Is that alright? So let's hit the OK
What
together.
of this?
This,
Yes.
yeah, you leave this as this default. Okay. So we'll hit OK now. Did you notice anything out there? Did you notice anything? Okay. Yeah, it's all dependent on the hydrogen level of hydrogen that we actually lost here. Okay, some of them as they add, I can't take this camera. So as they add, you discover that many of them will become what? Will become charged. Please give me a minute.
But this is offline.
Yeah. Okay, so no, they carried me again. Okay, so we just added the hydrogen atom now. We've added charges, right? So we can now continue. So we're done with editing. After editing the protein, the next thing with respect to the preparation is now to uh, carry out what, first of all, you save what you've edited. Okay, this is the kind of the upgraded version of your protein now. Is that all right? So after this, you are going to save it. Then after saving it, the next thing is to now generate what we call the grid box or the grid coordinate, which is a direction of where your protein, your ligand is going to what, bind to that protein. Is that all right? Okay, so what do we do? We'll have to save this first, and we save this by going to grid, not file. You go to grid, you hit on grid, and then the pop down menu will show. Then you hit or go to macromolecule, and then you go to choose. Is that fine? Okay, then you can hit on choose. If you hit on choose, a pop up or the pop down menu will show here. Is that okay? So you do what? If you click on this select molecule now, do you see what it's telling you? Nothing is selected. So don't be in a haste to go and click select molecule. So you go to grid, go to what? Macro, go to file, and go to this, and then go to what? Choose. Right? You have to select this first by clicking on it. So it has now identified as this protein you're talking about. Then I can now go ahead and what? Select molecule. Is that alright? So I'll click on select molecule. Okay, let me see. Okay, let me fix this. Okay, so here we are. And the next is to save this, like I said before, we can now generate the box. So what do? I'll go to grid, I'll go to macromolecule, and then I'll go to choose. Okay. If you hit on choose, this will pop up. You just highlight on the words, the protein by clicking on it and click select molecule. Good to bring out this. Okay, let's see. Okay. Okay, yeah, I think we've been able to fix that.
Wait, why you saved it? How did it happen? Why?
No, we'll do that again. Okay, so this is where we are. We're having a little clashes before, but we've been able to fix that now. So we simply save this macromolecule um, by going to grid, going to macromolecule, choose, and then hit on this and then select. Okay, if you select, it's going to initialize. Okay, and after initialization, it will tell you that this macromolecule has no non-bonded atom. Okay, if it has no non-bonded atom, what does it mean? All the atoms are bonded, right? Which is what it's supposed to. Just hit OK. If you hit OK, it should take you to your folders. Okay, so I have to navigate to where I am, which is in my downloads working folder, and then this is where we are. So it will tell you no item matches as well because this is saving as what? No longer PDB but what? PDB Qt. Okay, so I will simply say go ahead and save it. So I'm done with the saving now. So the next thing now is to generate my grid box. Okay, is to do what? Is to,
Generation of breeds.
okay, is to generate my what? My grid box. So what do I do? I'll go back to grid again. Hmm? And then I'll go back to set map type. I've left macromolecule now. I'll go to set map type and then I'll go to set directly. Is that fine? Okay, then I'll click on set directly. And by the top left corner, something will appear there. By default, it will tell you that the map type was set at that particular yeah, format. You just click what? Accept. Okay, you just accept it. You accept map type. Whenever you are trying to generate a coordinate, there's always a need for map. Map tries to locate uh, where you're actually looking at. Okay, so I'll go back to grid again. I've set my map type. The next now is to generate my grid box. Is that alright? So I'll click on grid box. Then if I click on grid box now, um, as you can see, yeah, it has placed a box. This box is where this is going to bind, where my ligand is supposed to enter and bind. Okay?
You are still in the protein. This is still the protein.
Yeah, this is the protein. But funny enough, this is um the pocket where that heme group is. Remember, heme group is a big atom, so it has assumed to be the main pocket of this protein. So, but if you didn't understudy this protein, you simply go and use this as your active site. And by doing so, you are intentionally or unintentionally targeting the wrong pocket. In fact, most people that work with this, except for the few of them that knows active site study, will always go and dock here. And when you go and dock here, you that they are hoping on is now the one misguiding them. Is that alright? So these cogs have two sides, I already know. This particular one where this bound now is the peroxidase site, which has a larger pocket because of the heme group. So this by default will expect that. Then how do we now locate the pocket where um, what is it called? Where the naproxen, which is the membrane binding domain, where we're interested in. Are you getting that? So to do that, I told us earlier that each amino acid in this particular protein has a coordinate. This is what I mean by coordinate or has centers. It has center X, Y, Z. Whenever a box is concerned, a box is like a cube, right? It always have three major sides. Is that also? So this is like the X, Y, Z of this. If you change anything here, this will certainly change. Look at what I mean now. If this goes this way and then this goes this way, are you noticing anything? You get that now? So automatically this will keep changing. But we need to locate where our own is. That is where the knowledge of that Agini 120 in the membrane binding domain of this particular COX-2 comes into play. So we'll go to our discovery studio and locate adenine 120. That's not just the adenine 120, but that functional group we want to target in adenine 120. We're going to locate it and find its coordinates and come and replace it here. That's all. Immediately you replace it here, you find out that this box will go to that pocket. And then when you now target this, it's going to that. Is that okay? Okay, so we have to go back to our what? Our discovery studio, right? And then we'll bring back our ligand. Okay. Okay. We can even leave our ligand. We don't need to bring it back. I hope we know. We can take it out since we already know where it is before. So I'll simply find my adenine 120 here by clicking on this left side. I'll navigate down to 120, which is a very important product for us, or important amino acid for us, because of um, what it does here, which is binding to the ligand groups coming in. So I will click on this and then it will get highlighted in the protein. So I will now bring out this cursor in this protein window and right click. And then I will change the display style. If you are changing display style now, in respect to that you highlighted. If you didn't highlight anything, it will not change. So if you mistakenly highlight this way, and then you do know when you click here and you start doing like this now, you are already doing another thing. Is that okay? This did you get what I just said? I was saying that remember we highlighted this and then this get highlighted before we now do right click to change the display style. If we are changing anything, is with respect to this thing we just highlighted. But assuming you highlighted this and maybe you are doing something else and your hand clicked here and that highlight left. If you go to do right click and start changing display style, you are not doing anything with respect to that. You are doing something now with respect to the entire protein. You see the protein is behaving. Is that okay? So we'll take that again. I'll highlight this, then I'll right click. I will go to display style, okay, and change it to ball and word stick. Okay, I'll now say apply that, and that's okay. So you will notice that the ligand has been uh, highlighted there, and then you can see arginine here. Okay, this is the arginine. Okay, I think we might need the role of that ligand at this point so that we'll be able to notice the point of the ligand that is closer to a particular functional group in this arginine so that we know the functional group. Even though we've done that yesterday and discovered this was the closest. Do you remember? Yeah, but okay, let's just bring it back so that we can just refresh our memory on that. So what do I do? Okay, I can use this. You see, trying to bring back. Okay, I brought back the ligands by just doing Control C to take me back to that. So let me remove the wanted ligand here now. I'll change this to select mode, and then I can take away this. Delete that and delete this, and then this is it, right? Okay, so this is what I have. Let me bring it closer now. Okay, so at this point now I can now highlight the arginine 120, right? This is it. I can now change it to ball and stick, right? Okay, I can now apply and okay. So by doing this now, as you can see, I've been able to. This is not rotate. Let me put it in rotate. Okay, look at it here. Okay, trying to get a better view of this. Okay, this is better, right?
Mm.
It's fine. So, this is the two reacting group, okay, and their closest here is either you target this or this, but I think if we zoom closer, we might discover that that center one could be um, could be the most closest there. Is that alright? So this could be, so you can target this or this actually. Okay, yeah, you can target this one. But for the sake of this, let's target this. So if I want to know the coordinate of this particular one here, I'll just tap on it and then the coordinate will appear here. Alright? Are we there now? So if I tap on this, the right up under here will certainly change. So I'll tap on this now and you're going to find arginine under here. Okay, it will go if I leave that. You're going to see arginine 120 ME, right? Arginine 120 what? ME.
Is it?
Yes.
Okay.
Okay, so take note of that. This is all I needed here. So I will, okay, okay. You already know that by default, arginine is inside that pocket. What you are targeting is an amino acid in the protein, not in the ligand. Are you
Wait,
getting
the
it?
amino acid in the protein.
Yes. If okay, if you don't have a ligand there, okay, you might not know which one is closer to the ligand, right? Okay. In such case, you simply target the exposed group of that particular atom or amino acid. The exposed group in this case could be this, this, or this. These three. When you say exposed, you also mean the group that were pointed out to the pocket. For instance, now you saw hydrogen here, hydrogen, oxygen here.
Mm.
Oxygen is pointing. Can you see that you can't target this particular one? This is the pocket. So this is the group pointing here. Rather, this oxygen here, can you see where it's pointing at?
Mm.
So you cannot go and target this oxygen. This thing will blindly go to buy another way. So if you don't have a ligand here, when you locate that atom, simply target a group, any group in that atom that is exposed to the pocket. So out of this is exposed. However, these two are more positioned towards the pocket. Are you getting it now?
Mm.
So we have agreed that we are going with 120 ME, right?
Mm.
Okay. To locate the coordinates of that 120 ME, we have to now use our Gauss view. Use what? Our Gauss view. Gauss view. Not God. Gauss. Yeah. I think one of you, maybe two of you were opening your protein yesterday.
Even me.
Uh-huh.
Even me.
Because by default, yeah, by default it's appearing as this thing there. Okay, so we'll, yeah, to know our coordinate, which is the center x, y, and z. That's the essence of all we are doing now. And this is what we call the site specific docking. I'm sure we've mentioned that before. Okay, so what do we do? We will open our Gauss view, like I said. If you have installed that, you'll find that um in your desktop. Okay. This is the Gauss view. This is the Gauss view. So you double click on it or single click depending on your system. So if you click on that, it will tell you Gaussian, not what? Install. Yes. You just click OK. And this will come and just keep clicking OK. And then it will do what? It will load. Is that alright? So I'll close this one. And then I'll minimize this. And then I'll open up this. This is the main window. Okay, I want to repeat this. We'll close this. Okay, you simply click on this and double click on that, and this will appear. You click OK, this will appear. Just go ahead and click on OK, and it will load. And when it loads, of course, these are the adverts. Click to close this. This is the two words main window. This is where we're interacting with. Just like Autodoc 2 has two windows. Same here. So we'll just minimize this and open this one. Is that alright? Okay, so the next thing is to bring in our protein here, the cleaned one that has no ligand, only protein, right? Because we are looking for arginine 120 ME in our protein, not in our ligand. So we bring only protein here. You do that by going to File, as usual. You go to Open, then you can locate where the protein is. Okay, so this is um, in our download. However, okay.
When you go to file, click open.
Yeah, you click open. Okay, so this is download. The last file I opened here was my T folder. Okay, so these are under the T, inside the T folder. So I'll have to navigate to my what? To my downloads, right? Anywhere you open this, of course, the next thing you should do is how you get to your folder. So I'll do that by clicking my user here, just by your right here. If I click on that, I'm going to see, of course, the normal options you have here. One of them is my download. So I'll click on download, I'll open it, and then these are in my download. This is already arranged alphabetically in this software. So I'll go to what's that name of that one? Tutorial something, right? I'll go to T. Uh, Workshop. Okay, I can use this arrow to go back there. You have T, UV. Okay, so it's not yet here. Tutorial, right? Okay, this tutorial class, right? So I'll open that, and then this is what we'll be working with. Uh, this is not all. So if I shift backwards, I'll see the remaining. Okay, this is where it stopped. This is what we have inside there. Is that not so? Okay, so this is our clean protein. Did we get to this point? Are you confused?
Yes. This plain protein, is it the one you remove the ligand and just
Yes, yes.
not that one you were trying to save and fight on?
No, this one is now the one we are now working with.
The other one, the one you want to.
Okay, we are coming to that one. It's still here, as you can see. It's a big, big pattern. That one is still not doing anything with it. So I will now double click on that depending on your system. Then,
So why are you moving your hand?
eh?
Depending on the system.
Yes, my own is set on single click. So I do click single.
Sorry.
When you're doing your hand like this, like you're pointing.
Okay, my hand is cooking. Okay, sorry, I'll be doing like this. Eh?
Back also.
Or like this. Okay, so it will ask you, would you like to add hydrogen to your structure? You just tell them no. Okay, and then this is the protein. Okay, is that alright? If you look, this actually resembles what we had earlier when we opened it here. Okay, so this is just the protein. However, you won't be able to visualize it here, so we'll minimize this as well. If you come to this now, you see this second to the last file. What is written there? View slash edit file. So this is where we can view that thing we just opened now. Is that alright? So if I click on it now, the protein will come out. Is that okay? So I'll click on this. You can see the protein is out here. So I'll simply expand it. This, remember our protein started with what? Number 33. Is that not so? This alanine now, this tool will expose all the atoms in each of the amino acids according to their coordinates. By essence, alanine has how many atoms? It has the nitrogen, it has carbon 1, carbon 2, oxygen, carbon 2. Okay, this is where it ended. Okay, all these are for what? Okay, starting from here. Are for what? The first alanine. Then you can see asparagine till here. You can see proline till here. Is that alright? However, we are on what? 120, arginine 120, isn't it? So we'll move down to what? Arginine 120. This is what you're looking at. Um, so I'll go to 120. Okay, so this is 120, right? This is arginine 120 here. Is that fine?
You highlight.
No, you don't. I don't want to. I just want to show you. Then in this 120, we are looking for arginine 120 what? Ne. Is that fine? Thank you. That's okay. So this is the Ne, right? This is arginine 180, 120 Ne. Look at what we're looking for here. So this is our center X, Y, and Z. X, Y, Z. So what do? I'll simply copy this X, Y, Z. I'll copy it. You can open your notepad. Okay, you can open your notepad just to paste it. Okay, I'll close this. Paste this. This is my XYZ, right? Okay, if this is taken, I can now copy this to
Coordinating.
remember. So I'll take this to my Autodoc 2. I'll copy this first one. I'm already done with this two. This Gaussian view. It has exposed what I'm looking for. Yeah, I just need to do this. So what do? I'll copy this and then I'll go to that two. Okay, you will notice what is happening as I paste this. I'll paste this first one, right? Then I'll click outside. I'll go back to the notepad and I'll pick this as well, right? I'll copy it and then I'll come here. Paste it. Do you notice anything there? You see that, right? Then I'll come to this now and I'll pick this one as well. And then I'll come here and I'll paste it. Do you notice it shifted again? By essence, it has left that main pocket to where our this is supposed to be. This is where it's supposed to be. So anything we're targeting now is coming to that. Is that fine? That's okay, right? So I will need to save this setup now that I have. I need to save it somewhere. So what do? I'll simply go to file. Some people will use paper and pen and copy all these things out. Okay? For me, instead of copying that, I'm making mistake with a number or so. You can save it as a file. Keep it somewhere. You can always open it in certain minutes. Is that alright? So I'll go to file. I'll go to output grid file dimension file. Output means save. Is that okay? I'll click on what? So I'll click on output now. Then of course it will take me to my folder. So I'll go to my downloads and then go to tutorial class. Let everything be inside this. Of course, there is no text file yet here. So I'll save this as grid dimension file. Okay, and then I'll save it. Is that alright? So I'll save it. And then I can now close this. I've seen where this is. So I'm okay with this. So I can close this now without saving. Is that alright? Do you get that now? The essence of bringing this box is to know where my lanyard is going to. Is that so? I'm done that. I can take the coordinate. So yes, this and this and this. You see 40 40. If okay, by default it will give you a 40. Look at what will happen to that. Do you see that?
It's supposed to be a square.
This will be inside. This particular one cannot shift this from one position to the other, but it can expand the size of it where it's located. Why this automatically positions it. So these two works hand in hand. Are you getting it? By default, this is left at 40 40. If you expand this, what you are telling the ligand is that you can bind anywhere around here. And the more you expand it, the more the ligand can do. You go and bind anywhere. Do you understand? However, if you make it too tight as well, the ligand might find it difficult to bind. So you just leave it at 40. Personally, I'm leaving it at 40 or at most 35. Is that alright? So that is just that. So that thing we saved out will still give us this. And even this, you see this spacing, some people while making their publication, you hear something like with coordinate x, y, z values of this and spacing bracket Armstrong value of this. Okay, it's just an additional information. Doesn't mean anything. Okay, so we can now. They told us Armstrong value. No, I can leave it like this. Once I close it, this will disappear. They told us of that Armstrong unit yesterday with respect to resolution. Assuming that maybe we are doing an investigation or wanted to get our rating gate, and that resolution is part of what we are checking. So aren't we going to copy other resolution to make sure it aligns with it? No. That resolution there is just telling you about the quality of the protein structure, the 3D structure of the protein. Are you getting it? Yeah, whereas this is just all about the coordinates, that focus. Yeah, you can save this. So this is what we have. So we can now close without what saving. And then this will disappear. Is that alright? Okay, so we are done with this now. The next, we just output it. Okay, you output this file again. Yeah, you go to grid, and then just like saving it. Yeah, saving it again. This time as a GPF file, even though you might not need the GPF file for anything, but it's just an extension that you know some tools for energy calculation might need it. Okay, but at this case you don't need a GPF, but we're going to output it. So you just click on save GPF file. Is that alright? And then when you click on save, it will certainly take you to your folder. So we'll get this and then this, and then you can save this as GPF file. It's still saving inside tutorial folder. Is that alright? Okay, so we can click on save, and then we are done with what the protein. Alright? So click on that to highlight it yellow, and then you right click on delete. And you get it off. Is that okay? The next thing is our remaining thing is our ligand, right? Okay, so in our ligand, we simply go to the ligand option here. No longer file. Go to what is the ligand option here. Okay, beside the grid, you see a ligand option. Is that alright? So click on our what? On our ligand. So when you click on ligand, it will give you a pop down menu to input and all that. So I'm going to hit on input. Input is like importing your ligand, right? So I will import the ligand, and then I'll go to open. Not choose now. You're not choosing anything yet. We are opening it, right? So I'll click on open. I can go to downloads, and then I'll go to tutorial folder, and then of course because I'm opening something from this tool, it can only show files I've saved in the format of this tool, which is PDB20, right? So, and I'm looking for ligand in PDB. Do you remember? So, what do? I will come down here and change the file type to all files. Is that alright? So, if you click yours like this and it shows like this, doesn't mean you won't answer. Yeah. Should I come again? Okay. I said that if you want to load in your ligand, you don't need to go to file. Not that you need to. Okay, so we are continuing. We want to load in our ligand now. So you simply do what? Go to ligand, click on ligand, click on input, and click on open. Okay. So when you open it, you can um, go to your folder, and then I was mentioning when you open your folder, you discover that nothing is here, right? Yeah, except your yes, because this is the only one here in PDBQT, which is the default format of this tool. So you have to come down to file type and click on what? On files, right? So that the rest can now come out. So I can now select my lab exam. Okay. Then to be loaded, I just say what? Okay. Is that alright? Yeah? Yes. Okay. Yeah. Okay. So this is what we have. This one that I just want to show us is going to be very quickly. Mhm. The main essence of bringing your ligand here is just to um, save it out in PDBQT. Do you understand? However, just for detail's sake, you might want to have one or two information about your ligand. That doesn't mean you are adding that information anywhere in your docking process. But maybe you just want to know one or two about your ligand, additional details. Okay, so you will follow me quickly as I show us that. But if you know, we take time, we'll just jump and pass now.
Not quickly, slowly.
Okay, so this is the ligand, right? Um, to get or know few things about your ligand again, you simply go to the same ligand we have inputted. So we go to what? Torsion 3. Okay? You go to torsion. The first thing you do is to dictate root. Okay? You dictate root in torsion 3. So I'll hit on dictate root. A box or a ball will appear here. This torsion is like this ball appear here is like the root where your ligand could make uh, rotation or movement from. Remember, I mentioned at the end of this docking, your ligand protein complex is going to come out up to 9 different conformations. Trying to tell you that as this ligand makes some interaction within the active site, it keeps generating different conformations. Is that all right? So this is trying to tell you how, to what extent, or where the point of movement is likely going to start from. So this is the root. I will now go back to the same ligand again, go to the same torsion 3. I've detected root, so I can choose torsions. Okay, as you can see, this is the root, and then these are possible points of interaction this particular group can make with respect to your uh, protein. Are you getting that? And this is a product of the complexity of the ligand. This is just a few uh, noticeable or notable functional group present in this ligand. Is that not so? This ring is just carbon atom. Then this is where you have oxygen, hydrogen, the same thing as here. Is that alright? So if there are notable interaction, it should be happening from this protein. So as you can see, this was giving us about what 3 out of 32 possible uh, yeah, possible rotatable. You can see number of rotatable bonds. As it's doing that, that's point where it could make interaction with. Is that right? Okay, so I'll just say done, which means I'm not adjusting it. I'll just say done. Then lastly, I'll go to the same ligand again, and then I'll go to the same torsion 3 again, and then I'll go and set number of words.
The one is selected now
Is choose torsion. Okay, just to see that. Then the next one is set number of torsions. Yeah. Assuming your ligand is so complex that it has over 10, 15 different rotatable bonds, he's now trying to tell you that that particular ligand could actually make a whole lot of interaction. Is that not so? And the more the interaction it could make, the more time it could consume to complete the interaction. Is that not so? So if you want to reduce that, maybe possibly you're not interested in the interaction, you just want to investigate pools and all that. You could reduce the interaction, the number of torsion by clicking on set what number of torsion. You can see we have three here. You cannot increase it, but you can reduce it. Are you getting that? You can reduce it, but you cannot increase it to the last one. So it was three, as we saw earlier. So you can, so if there are many, you can reduce it, but me, I just leave everything the way it is by default. Is that alright? So I can now click on what this is. That is all. These are just the few information you can pick with respect to your ligand. Is that fine? Is that okay? Okay, so you can now output this. You can save this out now by going to what output and saving as PDBQT. This is still the same as bringing your ligand here and saving as PDBQT. Just that. Yeah, you go to ligand. This, no, this has no nothing this thing. The first one was protein. Oh, not save this. Yes, yes. So I'll click on save as PDBQT and then I will navigate to the what the folder, right? Okay, so um clicked on this, so it has reflected here. I'll have to repeat that again. I'll go to this and then I'll navigate. While opening that, make sure you don't click. Do you see now? This has appeared. But firstly, when I opened it, I clicked on this. Once you tap on this name will appear here. I'm not showing us few things
You
that
cannot clean it.
if you clean it, you must write exactly what.
Um,
Yes, you must write exactly that name. Is that okay? So that is it. So you just have to be a bit careful with that. So this is what I have. I cannot save. Is that alright? So I'll save this. And then I'm done with this. So I can go ahead to click here. Right click and do what? Click on delete. And this will go right. Okay, so I'm done with this. I'm done with orthodox preparation. Okay, we're going to do the last portion of this. And then, yes. Okay, so this is what I have. To continue in the next activity, and we are done preparing the protein and we're done preparing the ligand, right? Okay, so the next thing we do is to prepare what we call the config file. The config file, the configuration file. Okay, it's called config, CONFIG file. Very, very, very important. Okay, this config file is going to contain just the details for the document, and that is what the Autodoc Vienna docking tool is certainly going to be making use of in performing your docking activities. Is that all right? Okay, um, so we can continue. Um, we're going to save the prepare the config file, right? Okay, and as we know, this config file is going to be a file you prepare just once. The file config file I've used for over 100 times was just prepared once. The next thing I'll be doing is just to edit it and work with it, right? Okay, this is an example of a config file. I will simply go and okay, let me check this so I can easily pick one and then show us what it looks like. I don't need to just prepare everything afresh. Okay, this is config file. I will copy this to my tutorial this. So I'll post this. Okay, let me open this so that we see what it's all about. So this is an example of what? Of a config file, right? Yeah, this is a WordPad. Is it WordPad notepad? Yeah, this is notepad. So you know what it means now. Yeah, you want to compose. Okay, let me close all this. Let me close all this. Okay, all this in notepad. That's why. Now you sabi. Okay, so this is a notepad file, right? Okay, this config file is going to be what? You're going to see something like receptor. Receptor is talking about your what? Your protein or your target, right? You're going to have this target now. This is my target, right? I'm going to edit this with respect to our protein now. Then this is my what? My ligand, right? This ligand is what? Your normal compound. Is that also? Then after that, you hit an enter button, right? You know what I mean by enter? You hit an enter button to give this space. And you just type center underscore X. Do we know how to type underscore? And you put down your shift and then this. Is that alright? So underscore this. These centers are, do you remember? Coordinates. Yes. And then this sizes. Remember the sizes? Yes. And then lastly you just put out. Out here means output or product or result, whatever you want to use here. By essence, when the docking is completed, a file having this name will come out. And what it means is the file has your output, your result. Okay. You're going to actually have two new files added. The number one file will have your docking scores in form of a log file. Okay. You see that. And then this will have, you can see they can all the PDB put. This is about the all the ligand protein complex, the 9 different combinations will come out as this and all that. So we get to see that.
Is it must that you do this config file using a notepad? Like Microsoft Word cannot be used.
It can, as far as you can save it as a text file. Does Microsoft Word save as text? No, you can. He's talking about it. Does Microsoft Word save as type? As no, you can just. I can't remember the extension of that, but I think Word has its own. It must save as text. Save, I think WordPad or Notepad, all those two save as text file. That's just interest here. Okay, so and you must. So in this case, we don't need all this now. So I will take off this, take off this, then I'll take off this, right? I'll take off this, and then I'll take off this.
So while we were saying that some people do write it down, something you wrote down in that place, you come and write it when we're in that goes to you. All these coordinates, you can
Yes,
write it down and come and type.
yes. You can write it down with your pen, provided you don't make mistake. So whatever. If you can save, if you are too good in this and you can save this in text file, that's fine. The essence is just to get it saved in text file. It's fine. Alright. So we can now open our folder and locate our grid dimension file. Do you remember that? Okay, we can open this. It's asking us what to open that with. Okay, no, not okay. We can open with the same notepad. Later we can close it. We just have two windows. Then also
When you open the folder, go to the grid.
dimension file. That file that has the details of our X, Y, Z
Okay,
things.
so this.
So if you click on it, this is what you just outputted. You understand? This is the spacing, this is the 40/40, and this. So I'll simply copy this first one, copy, then I will save it for what? Because there will always be space equal to space, right? You don't mix them together. In typing this, however, I can send you a copy of this, but you don't, while typing it afresh, this equal to everything shouldn't join together. Yes, exactly this way. So I'll go back to this, or I can even do like this. Yes, I'll come here and paste it. Then I will now copy here and put here. And this one is too far. Copy this, put X, and then I'll paste it. Is that alright? So I pasted my coordinates. Then I can close this, right? But my receptor and this is not here, right? So I'll go to my folder. What I'm copying here now is the ones in PDBQT. The receptor and the ligand in what? In PDBQT. So, and to do that, you you won't just do copy and paste. What you are copying is the name of this, not the file. Not the file. You're copying the name. So it's either you type this name as it is, which is a bit risky, or you simply do as if you are renaming this and now copy. So if I do like I'm renaming, you either right click and go to rename this in my own software. This is rename, right? Or I can simply click on this A up here. It simply means rename as well, right? If you look now, it's only highlighted the name and not the extension, right? So you have to manually highlight everything here now do copy. Then you can now go to most time you just minimize this and then have the two side by side. So you can now paste your receptor here, right? Then it remain my what? My naproxen, which is this, right? Come to this. So to highlight, you can rename that. As you can see, you can as well do Control A to highlight everything, right? So I can now do Control C and copy it and I'll come this way, then I'll paste it.
Oh, can you go back to that protein?
This is the protein.
Okay, you didn't take this one in the protein.
Why not? This is what I did for the protein. And then yeah, I went to rename. Only this was highlighted. I had to do Control to copy. Look at the protein. It must be in PDB protein. If you remove this T here, it will not work. You keep having challenge trying to do this. Everything here must be in this. You see this file? This file is very, very important. Okay? So that is all we have. Um, then we can now save this file. This file is ready now, right? Is that alright? So we can save this file. If you opened your config from another folder, here I've already copied it to this folder, right? So it's already in our folder. If you opened it from another folder, after editing, you simply go to save as and save in your new folder. Do you understand that? Do you understand that? Are you with us? So, but here, from starting now, from starting now.
Not being that tutorial classroom.
No, it's already there. We have already copied it to them. But I'm saying, assuming you just searched config, just to locate a config in your file. Yes, it's not in your folder. You can open it from anywhere. After, you don't even need to copy. You can open it from anywhere. After working there, you can now go to save as and now locate your new file.
Number and save in that.
Yes, in that your new folder. So now that I already have it in my folder, I can just do Control S and save it because it's already in my folder. I opened it from my folder. Do you understand? Yes. Is that alright? Okay, so this is what I have. I can now close this. And then that is all I need to prepare for this. So my next thing is to open up my command prompt. Okay, you go to your search, then open up your command. so that you can now do the docking process gone now. So I will click on just type. It doesn't require programming. You don't dey shape now. Okay, so click your command. Every system has this, right? You don't need to install this. So you click on that and then it will open and will expand that. So this is what we have. Is that alright? Okay, so basically what this will help you to do is to simply um bring up the tool, the software you're going to use and then bring up the file you want to use and the file. Remember now, everything is now contained in which file?
Config.
In the config file. Do you remember? Everything is there. So what you do here, you simply bring in the tool, which is the software, the Autodoc Vina, then bring in the file you want to dock, and tell the file after docking, give me a product in this, and that's all. So whatever we are going to be doing here is just to locate the file, locate the folder, and that's all. Locate the software and that's fine. Is that alright? So the first thing I do is to come to this folder where I'm working from. Okay, this is the folder. Yeah, this is the folder I'm working from. Is that alright? So this is the folder I'm working from. Alright. So I'll need the extension of this folder. Okay, or the directory rather, the directory of this folder. So what do I do? If you see this place, there is a kind of a what do you call this? A directory line here, right? If I click anywhere here to highlight that in blue, do you understand what I just did? You will see everything here, but if I click, it will highlight in blue. So I'll just highlight and do Control C. I need to copy that. These directories for this folder. Then also, don't worry about them. The tool knows what is interested in. Okay, so just pick what is interested in. So I've copied this. I can now return to my words command prompt. The next thing I will do is to change my directory from this. This is my default directory to that folder. Okay, I just copied now. That folder is my new directory where all I want to do is placed. Is that not so? So CD means change directory, right? So I'll means to change directory. Change directory. Okay, so I'll type CD and then I'll give a space option. Alright, and then I'll right click. Okay, I'll right click on your mouse on your keyboard. Once I right click, that directory I copied will appear here automatically. So I'll right click and that has appeared automatically. If your own did not appear automatically, an option like paste will appear. For some system, when you do that, an option like paste.
Why are you touching her?
Imagine. Okay, so this is what we have, right? Then I'll hit on my enter button. If you hit on your enter, you have changed from that to your new destiny now. Is that alright?
Yeah.
But then you cannot remove this and just
No, you
paste.
don't need to.
Okay, your cursor will be here. If you click on enter.
If you click on enter, it will now, this folder now has this arrow. That's how you know
Like,
like this. Is that alright? So at this point, I want to now call in my tools. I'm calling the software that is going to do the docking, which is the Autodoc Vina.exe. That is the Autodoc Vina software that's going to perform the docking. I'll do that by typing backslash p. Backslash p is to find the path. Okay.
to find what?
The path where the software was located. At the course of the installation of your software, you discover that there is a file, you might not know, but there is a file called the Script Institute. What do I call it?
Discrete.
Yeah.
Discrete what?
The Script
Okay, discrete.
Institute. They are the institute that hosts or that owns Orthodox Villa. Is that right? Orthodox to umbrella. So I took that folder to your local disk, where precisely your local disk 86. That is where your softwares are being installed. If you install any software, to go to your local disk 86. Is that all right? So I simply took the same extension file folder to that same directory. Okay, so that when you come here, you can simply trace from path and go and get it there. Is that all right? So this is what I want to do now. I'll type \p to find the path, and then I'll click on my tab button. There's a tab button here. Okay, I'll click on my tab button, which is just above your cap lock in the web system. If I click on the tab, all the um, files or the folders that started with P in that part will start what appearing. But I'm looking for program file 86. So I'll keep clicking on. Do you see I passed that? I'll keep clicking on, look at it. Do you see? Yes, just on the tab. So in case you want to click on your own and then you were clicking and you didn't know when you reached it and passed it, you don't need to start afresh. You just continue doing clicking. It will reach end and it will return to that. Is that alright? So I found the folder. Then inside this program file exists. I'm looking for yes, it's for all systems. You have local disk. You have program file, you have program file exists. This is where system automatically installs software. Alright? So inside this thesis, I'm looking for the script institute. So at this point, I'll still backslash again, but this time I'm looking for T. The script it started with what? T8, right? So if you remove this T and just type only backslash, it will solve all the software, all the folders you have inside this program file thesis. But if you write T, it will move down to those that started with T. Is that right? Okay, so I'll just put T or look at what I'm saying. All these are inside that place. You can see it's still in I, M, and all that before it got to this. But if I simply type T and hit on tab, it will locate it in the. You understand that? Okay. So inside the descriptive institute, there is a folder called Orthodox to call the Orthodox Vina. Okay. We usually call it for short Vina. Inside that folder. If you open that folder, you see Vina and you see Vina.exe. Okay. So I'll simply backslash again and type V just to locate that Vina. Okay. If you hit on tab again, the Vina will appear. Alright. Then inside the Vina, I'm looking for Vina dot the forward slash. Okay, let's see. If you put forward slash, you see what it's giving you. What do you notice is happening here? What do you notice?
Maybe not the file is saved in the folder.
So I'll do backslash instead and do what? V. If I do only backslash without V, what do you think will happen?
Everything.
Okay. Okay. So I'll just do V. And then only Vina has a V
That
there.
type if you click enter.
Yes. You click tab. Yeah, if you click enter now, you are moving from this line of command to another. So at this point, inside this Vina, there is nothing else in Vina except Vina.exe. So if I just click the next backslash and hit on tab, it will locate the only file inside it. But if there are many, I would have clicked an alphabet, right? So I just hit a backslash and then this is it. Now this yes, a tab. Then at this point you have located your software. True or false? This Vina.exe is the document you see that is the Orthodox Vina. So if I hit enter now and then the tool is installed here, it's going to read, okay, and tell me that this, and then is that alright? So I'll hit my enter button and then this will read out. Okay. In your own convenience time you can read what is all here, but this is just trying to give you detail about what you have inside there, what the tool is going to do, and all that. Is that all right? Okay, so at this point now, my software is fine, is well positioned. I've located it. The next thing I will do here is to now command the software to pick my config file. Remember what the config file is? Pick my config file, work on it, and give out my output in this file, and give it another file as well. Is that all right? So to bring back your last command, before you do that, you have to bring back the last command which you used to, check this software. You already know that. So you bring back that last command by hitting on your upper arrow button. After that is reading, or after that has finished reading, this same line of this thing part will show, right? But you need that last command you used earlier to before hitting enter. So to bring it back, you simply press on your what? Upper arrow. You know what arrow means, right? Hit on your upper arrow. If I hit on upper arrow, this thing will appear. You've come across this before, right? Okay. So once this comes out, the next thing you type is to give a space. Mhm. You give a space and you click on two hyphen. Click two hyphen from hyphen. And then you type config space config dot txt. You are telling it locate config.
After the two, you give a space.
No, space two hyphen type config. Then you give a space and type config.
Space, two hyphen.
Yes,
Then you type config.
yes. Then give a space and give.
It's my phone. Type
Okay.
config, another space.
Config.txt. You are telling it now to pick a config file, and this file is a what? A txt file. Is that right? And then at the end, you also tell it to give you, by repeating the same thing, space, double hyphen, a log file, and the log file is going to be a txt file as well. You tell it, produce a config file, mhm, pick a config which is a txt file, and produce a log file which is a txt file as well. This is all we are going to have typed here. Then the command level is, mhm, the software now have, yes, they have understood and speak this the config file now. Then after everything, the document now is going to give out. Remember in the config, we have already saved an output as data all PDBQT. Do you remember?
Yes, yes,
Do you
yes.
remember in that config file there's something like,
Okay.
yeah, you have out, then that's the last one on that. That one will contain the result of the different 9 protein ligand conformations after docking. But this output we are putting here, this log file here now, will be the docking score. Okay, the 9 conformation have their different binding images, which we are going to see. So that's the essence of this. So you are going to have 2 new files that are going to be added to your folder after the docking is completed automatically. Is that all right? So if this is correct, you hit on your enter button and docking will commence. So I'll hit on my enter button. If you hit your enter button and then you read like this is the founder of Orthodox Lunasis 2010. This reference, you must always cite this in your reference. If you use Orthodox Lunasis, you must cite this one. It is this Austin and Trot. And then the document has occurred already. And then this is, you don't dock like this.
On this own.
You saw it reading. Yes, once you hit your enter button to run, you can say that well,
Always in negative.
yes,
The higher the
we'll come to that. come to that.
The lower the
If you remember the file we used yesterday, you see they are reporting RMSD value, reporting binding energy, and some amino acids. This is the RMSD value. In all this, you're only going to pick one. Okay,
just one.
just one. Okay, and then in most cases, the one with 0.00 RMSD, which is the first one, is always the one with the highest binding energy. This is the binding energy negative, which is always the one usually P. So here you can see minus 8.3. And then I told us that it will generate at least 9 different conformations. These are the protein ligand complexes, protein like up to 9 of them, and their docking scores or binding energy or binding affinity. You can see here affinity. Affinity and energy is interpreted as the same. However, the lower the binding energy, the higher the affinity. That is true, right? The lower the what, the higher the what. Okay. Okay, so this is the output result. We're done with this now, right?
But we don't need it. But what if we don't see 0.0?
No, the first one is always zero. First one is always zero. However, at the end, you might discover that this first one might not be, when you investigate the result, you might discover it might not be your best here in terms of clues and all that. That might lead you to pick the second one. Do you understand? If you pick the second one and you must report the RMSD value, then you will report. Most times, we don't. I personally, I don't report RMSD, but some people can just put in every, even best mode this, you still see them put in there. Kajun and Ebu. Okay, so this is what we have. We're done with this. Alright? So I can close this.
This thing has saved.
It has saved. So I'll go back to our folder now.
Where did you save it? In the folder. Okay. See, it's two. This is one of the files that added. Remaining one.
This thing automatic.
Yeah. But not saved.
Okay. Let me just pardon all of you. Don't worry, you can be asking your questions.
Thank you, sir.
Because I've mentioned how many times that key files are going to automatically save into your folder. True or false?
Said it's true.
True, man.
So we saved
Come
one.
closer so
We
that
don't
you see
understand.
this.
We're thinking it's big controversy.
Okay, no. Right. So if I open this log file now, for instance, you are going to see similar thing as what you saw in that true or false.
Yes.
Look at it here. So these are the scores. So it is already here. You don't need to copy anything again. Aside this, you have another one. Bigger all. BDBQT. What did I say will be here?
The all the all fine. Is it not that one in that config? No, 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 no. This one is for config.
That is it not auto?
Let
This
me,
command.
let me not believe that people are among those that understand later, not presently. Mhm.
For some of us,
I say that this Legan or PDBQT is the second file. The first file will contain, which is the log file, will have your docking scores, right? Your docking affinities. While the Legan or will contain the 9 protein ligand complexes.
Okay.
I've mentioned that before. The 9 different poses we just saw that has the corresponding binding affinities.
Okay, it's
This,
here.
yes, it's already here.
But it's not that one.
It's just as
The log
number.
is just the binding affinities.
Affinity, the energy.
After this docking, you're supposed to see how the protein and ligand now came together. That's the SS, that's the docking, right? So with this log file, we couldn't see how we are going to visualize them, how they will dock together, how they are, see the interaction, the active site interactions. Do you understand? Okay, so this is where we are. So these two tools have been docked now.
So the two files that we cannot open this.
We can, we are going to open it now. So we have opened the docking score now. The next thing we do now is to open the what? The conformations now, right? Okay. We are going to do that by opening our file more. um, you just type final and then this will come out, right? You open it, it will load a little because it has as well a command window. Then mine has loaded. Always note that you won't expect your own system, the speed of whatever you're doing here is dependent on the system and all that. So if you want delay a bit, it doesn't mean it's not working, right? Okay, so we'll close this, including the loading of this software. Okay, so I will expand this. Forget this particular this you see here. You can always work without this later. Okay, so when you open your Pymo, this is what you have, right? Can you see that? So this is what we have. You have your file, you have your edit, this, and this. As you keep working, you keep interacting with many of these. As well, you have tools under here and all that. I think at this point, I might need my okay. I mean, I use it. Some people will say it's because I was using mouse. Don't worry, we'll suffer together. Okay, so this is what I have. Importantly, you can see a Pymo command prompt window, right? You can put your command. This is your command input area. If you load something here by using command, you can interact with that, right? However, all these buttons and options are for your normal interaction without command. So if you're not good in command, you can use that. You can color, you can change style, you can do all that by using commands, right? Okay, so the next thing we do is to load in our protein. Okay, yeah, to load in our what? Our protein, our clean protein. We want to load the clean protein and now load the ligands, all now the different line conformation into the protein. So first of all, load the clean protein that has nothing, and then load in the ligand. The ligand will automatically go inside the protein because we have already docked the protein. The ligand, the system will understand. So I'll go to open, okay, and then I'll navigate to my download tutorial, and then I'll open what now? The clean protein, right? So I'll click on the clean protein, and this is the clean protein. Is that right? The next thing I open is what? The ligand. Alright, which is this. So I'll click on that. And then, okay, I just open Control Z. I've taken it off. But you understood how to take this to zoom to disable. This is what I have. You got to here, right? Yes, I just click on open, go to clean protein, and click on it to open it. Right? Okay. Let's do that again. Okay. My system might not permit me to. There are options here, but because of the mini this thing here, I might need my mouse to go a bit down. I wanted to delete it and put it again. Alright.
What you just do, you went to find.
Okay, let me delete everything from all here. Let me delete everything. Alright? So I'll go to file, go to open, then I'll go to because I've opened from here, it just opened here. Yeah, but if it's not, you go to a download. This is the clean protein. So I'll just click on it. Here you will double click and you open it. So this is the protein, right? So the next is to open the link and on, which is the 9 confirmations, right? Okay, if I open it, I automatically go into the protein because it has been docked. But if you have not docked it, yes, if you've not docked it and you open it, it will come and open somewhere. Do you understand? So I will simply go to open as well, and then this is the link and on, and then this is it. So I'll zoom to visible so that I can be able to see that. Can you see that inside the protein? Can you see that inside? Okay, if you look down under your right, you're going to see 1 over what? 9, right? 1 over what? 9. It's trying to tell you that you are just on the 1 confirmation out of the 9, right? So if I click on my arrow key or I click on my next button here, either you click on the next arrow button or you click on this next here, you will see the ligand inside that pocket try to change. Are you noticing anything there? This is trying to show you how the different line conformation were done. Is that right? If you look here where I'm clicking, you have two arrows. This is 2, this is 2. This will take you from 9 to 1, and then this will take you from 1 to 1. All these are things I'm just showing you that when you mistakenly click this, you won't feel like you're making mistake and all that. The same thing, your arrow button can as well do that. Is that alright? Okay, so let's start with the number 1. Okay, remember our investigation is to check if this is actually interacting with um what's that amino acid again? Yeah, 120, which we targeted, right? Okay, so this is the first confirmation. I'm going to save this first confirmation and now go and view it. I can't see the 2D view here. Okay, with respect to these two. These two won't give you a better view. So I don't usually view this. So what I do, I will export. This is now a molecule. We call this a molecule, right? Yeah. This complex is now called a molecule. So I will export this molecule. If I export this, I'm only exporting the first ligand and the protein. Is that okay? So I will export this by clicking on what? File and then go to export molecule. I'll go to what? Export molecule. If I click on export molecule, what do you think will happen? Where is it taking me to? If I take it to office one, what do you want to export something from here? Won't you go to your folder first? You just export it, you just throw yourself to another software. Eh? Eh? No. You need to go and open another software. You don't dey open like that. By export, anything you click on file will certainly take you to a folder. File is trying to say, be it import or be it export or be it open, it's going to your folder. So if I click on that, it will ask me, it will bring up this option. It's a saving method, is that not so? Exporting is a way of saving it. So, but it will ask you, do you want to maintain the original atom model? Why this plays a role is if you have altered one or two, okay, in this code, maybe you've done mutation, you can use this tool to cause mutation, intentional mutation. I might decide to remove that one gene, 120, and put valine there and check the effect of valine with respect to that particular. Assuming there is a particular disease condition that mutation and that particular amino acid predisposes the individual to. Example is sickle cell, where change in amino acid or mutation in amino acid predisposes to the individual to sickling of the cell. Is that not so? Here we didn't alter anything, so we don't need to highlight this. Okay, we just click on save, right? It will take us to our folder. Of course, it's in our tutorial folder already, but there is nothing here, no match, because this is coming as what? A PDB display. So what do? I'll change it to what? To normal PDB file. And when I do, this will come out. I'll title this as molecule 1. Okay, it's a molecule which is or complex 1. Okay, let's use complex 1. Complex 1. Alright, it's saving inside here. So what do? I'll click on save. Did we get to this point? So I'll click on I've saved and false confirmation. Then I'll click on it to set the second one. I'm only going to do first and second. Alright. So this is the second one. What do? Again? I'll go to file, go to what? One molecule. What? So, and when I save this, it change to what? PDB, right? Then this will become what? Alright? So, you go to press something. Okay. So, click save. Is that alright? So, I can now minimize this. So, I will now go back to this, right? I'm going to use the Discovery Studio to view the 2D diagram, just like we did the other time. Okay? So, I will delete all this now. Even if I didn't delete it, if I open another one, it will still open as a new one. Is that right? Okay.
But
So,
I want to ask another thing.
mm,
This app that we software that we're using, does it require the use of any connection, internet connection?
so you can see I'm not connected. Is that right? Except you want to, some of them you can load in, some like PyMol, you can from PyMol load in 2D. Look at what if I go to my PyMol and I go to file, I can get a PDB file. I can directly download this protein inside here. If I'm connected, I'll click on get PDB. It will just ask me for the code. I'll input the code. It will go online and download the protein here.
Oh,
Do you understand that? And that's the only option where you can edit it. But if you downloaded it already, there is no need for that. Okay, so this is it. I'll first of all go and open file, go to open. I'll open complex one, right? Okay, I'll open complex one. This is complex one. Can you see the ligand inside? Can you see where it's bound? This is the heme binding side before. So actually it located okay, I would have even left the other one so that you can use that, but don't worry, when we do the 2D we will actually know that they are in the same pocket. Is that not so? Okay, so this is what we have. What do I do next? I'll hit on the 2D, right? So I'll hit on 2D. Let me see what it's going to give me. Like, okay, then um let me open up this. Okay, did you notice anything here? This is my ligand, right? What do we call this? What is this?
I don't want
This is engineer 120, right? This is the tyrosine what? Do you remember this as well? There is another one. What is that last one again? I think it's still something 7530 is here. Which other one can we? Tyrosine 385. That man, that article said. Do you remember that?
that is strongly bonded to.
Can you see that? Look at it. So our ligand actually located the pocket. Do you get? Not just the pocket, it actually bounded through hydrogen. You can see this tyrosine, this arginine in 120 in green is the strongest bond you can have in this interaction. We call it the conventional hydrogen.
So how do you know that this thing bounded? All of them looks.
Okay, okay, okay. Let me remove this. And then you can see I'm not using mouse. If I'm using mouse, I can zoom this closer. Okay, so but I can't do that without mouse here. So what I do, you can see the arginine, see a green dot. Can you see a green dot? It's telling you that it's dot is bonded here. See another green dot bonded to this. See valine bonded by this. These colors is what I just removed. The legend I just removed that. You use that legend to interpret what the type of bondings are. Is that alright? So you can see that here. Also, we have something we call, if you go in depth into this, where we are comparing between two ligands, which one did better, you might as well consider the bond length of the ligands with respect to the amino acid of interest. For instance, if I right click and go to display style, I can decide to go to interaction and add the bond here, the show distance, and discover that from arginine to this is about 5.6. Are you getting it? Yes. No, 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 no. This 5.6 is for this. This 5.6 is for this. This is 4.95. If I zoom this, it's because it's a bit clear. Okay, if I zoom it to you, so you can see that. Look at another one, 4.30. That's with respect to this. So tyrosine here had this is 5.8 what 7. Why this 6.21 is this one, this purple one that still come here. Can you see that? So the shorter the distance, the closer the ligand to the amino acid. Then also, these are in-depth. Yeah, the shorter the bond distance, the closer this to the line to the acid. So when you are doing this in-depth discussion in this kind of work, it gives flesh to what you're doing and to the extent you actually know what. Is that alright? Okay. Distance. I'll, no, that will be the number one and number two assignment. Going to check how is in Armstrong. Okay. So this is what we have. Just remove that. Okay. So we are going to save this. Okay, we are going to save this. Then show the second one. Try to okay, but at least I was able to show us what we needed to get there. So this is it, right? Okay, so I can save this now. Okay, if I click here, you can notice that this blue something is moving between you have up to two windows here. So this blue something is telling you the window you are currently working on. If I click on this now, I cannot go and save this. So I want to save this image. So I'll click on this. Then I'll go to what file. I'll go to save as. It's an image. So I'll save this 2D diagram complex 1 2D diagram. It's saving it to this. Is an image file, so I will just save it. It will ask me if I want to adjust this. I'll say fine. Is that alright? Okay, so this is what I do. What I have. So I can close this. Right? I'll close this. What do I? Okay, what do I need to do? Complex 2. Okay, let's see the complex 2 now. I'll leave this one here. Then I'll open complex 2. And then this is first complex, right? This is second complex. If you notice, as I'm clicking, you should notice a little. Okay, so this complex 2. I can read the 2D, right? Okay, if I hit on the 2D, this is what I have. Okay, let's see. Trying to compare this to the other one. Do you see that you couldn't get this? Couldn't get the one we targeted. However, it's in the pocket. I hope we know. But see the 355, he couldn't still get that through a visible bonding. However, 385, we have 385 in the other one too. It's somewhere here, right? However, it's 385 that was not exhibiting his current stronger ball. I think that was what that man reported. Like he exhibited three. Maybe it was something like this he was talking about, which was yes. From what you and I have seen now, the major one here is that 120 and 38 and what 355. It will bind to 120 and then 355 will initiate what they call bond abstraction. So this one is just for stabilizing the ligand inside the pocket. That you bound to this strongly does not mean this is actually playing.
Wait, how do you know the amino acid, right?
The minor seed that we do the abstraction.
You study. That's
Okay, that's the reason for
study. Have you listened to that voice? Yeah. Okay, so that is exactly what that is how we know
I'll tell you
something.
the distance.
Okay, the distance. Okay. If I go to this, uh, so you discover that this will show, and let me remove the legend so that you see. Okay, legend now make it become too good. Let me show legend so that it will get a bit. Okay, that's fine. So as you can see, this is it. This is the point. However, there is there's no almost no need of a point. There's nothing we're investigating here. If I'm docking this, I'll pick the first one, except I check number three, and it's better than the first
But if that delay bounded,
one.
if this 120 binds to the
If bounded here and bounded with a strong, what once is found here, you take the this. Yes, now
this very grey one is
this
the
very
stronger
thick
one.
one is the conventional hydro, that is the strongest here. The only one that had it is here. Then after that, you have a faint one, which is light, which is Van der Waal. You know what Van der Waal classes are? They are just forces for stabilization. So as you can see here, the arginine is just stabilizing here. It's not even involved in the unlike the first one. So this is how you know which one is actually I get that, but except those that know this in detail, they will just pick one like what that man was discussing in the way. And reviewers don't accept them to the public. So this is what you have. And lastly, you could have this and then you could have a little bit of a developed version of this just to customize this a bit. You understand? Just like what I'm already doing here. If I'm working on this, I don't save the ligand number one with the legend at all time. Look at what I mean. When you're doing this kind of work, you should have maybe an MS Word where you want to insert the result into, right? If I'm inserting this into the MS Word, you don't save this and this as an image and then upload it there. If you get there, you still crop this off and all that, and it will make this less visible. Right? So what I do is I will get one legend that tries to cover almost all the color here. Okay, if you study four compounds, you discover that there's one you open. If I open the other one, you discover that this particular legend here. Okay, let me see. This is the other one, right? Let me see how the 2D look like. Okay, let's say we have about seven here. Let's see what we have here. We have about six here. Even though this one as well wasn't too complex, there are also some dark ones we call the unfavorable bonds. I'm talking about here. This particular interaction only had about six different uh, kinds of bond. Look at it now, one, two, three, four, five, six. With respect to the colors here. While the complex two, okay, while this complex one have up to what? Seven of them. There are other forms of bonds. There is unfavorable bonds that are in red color that didn't appear here. Maybe if you keep checking, there's one you get, you find an unfavorable bond. Okay, appearing. So what I do is I will look for a legend that has tried to comprise of most or all the kind of bonds in that interaction. Okay, so that after pasting in my work, I'll only be posting these pictures, leaving this. Then at the end, I'll just carry one of these and put on it. Yeah, try to have everything. That is just what I'm trying to say. If you keep pasting this together, it will occupy space. Are you getting that? So that is what I wanted to show you here. So we will customize this, and then that is all for this. So what do I do to customize? I will right click Customize just to make it look more presentable, right? However, some people publish this. That one we saw was exactly this, right? So we could make this better. If I right click and go to display style is where you can change the style of the right? I can click on that. And then number one is show legend. I can remove the show legend. Okay. Then I can go to atom. The atom is talking about the legend, the ligand, sorry. The atom is this. Alright? This ligand. If I change this ligand to ball, okay, to stick, and hit and apply, you see how that reflects, alright? However, I will, okay, don't worry, let's leave it this way. At the end, I will explain that. So this is what I have. I've changed that, but sometimes this ball becomes too big. This stick becomes too big. You can adjust it down here. You can see stick size. I usually use one, and when I apply, it tends to make that okay. All these are what I do personally. So I cannot go to residue. Residue is the amino acid, right? The amino acids are in ball, but I can change them to this. Okay. If I click on this and apply, it tends to make the tip sharper, right? I can as well use plate. I think I've worked with plate also. It will make it done this way. And still make it a bit more visible. But I think this is more interesting. Then this size you can of course increase or reduce. Also the interaction here, I don't need interaction, so I will write it and apply it. Then I will say okay, and that is all. Right? But because I'm not working with mouse, this thing will make this project more. It's either you now open this, okay, and now copy out, or you just click on the legend and copy out. But look at what I now have. This is what I have now, right? To follow to this point. So I want to save this now. I can simply go to file as well, go to save as, right? And then save this complex, these two, name go shock you, 2D diagram, right? It's saving into here, so I see it. This will pop up and say okay, right? So this is what we have. Also, if you have saved like this and you're already working with the document open, okay, to copy or even if you want to work with the one you saved, open the one you saved and kind of do a screenshot of it instead of opening it as an image. If you copy an image and you start your work, you can find the image, what do you think will happen? The big blur because it's a picture, okay? But you can screenshot this or snap this, okay? Something like this, I think I've showed us before. You hold down your shift key,
Shift
your window,
and S.
and S. You hold down your shift, your window, and S. Then you can either right click or just double click and kind of crop. By this, I've snapped this. I can post this anywhere, share in my MS Word. Yeah, I can easily open a new file here and post this. You can see how bright it is. If I insert a picture, okay, so this is exactly what we have here. Is that alright? So I can close this now. This is what I have. Okay, one and two. So this is my um, ligand uh, protein complex. I've just viewed their 2D. That 2D you need it for your publication and presentation. Is that alright? Then lastly we do the 3D and then we're done with this. Okay, so the 3D view, I usually do that with Fine One because it's a bit more interesting here. Okay, I think we are working with our first complex. Okay, yeah, this is the first complex which we have agreed, except we check others and found a better one. But for now, the first one appeared as the better one. Okay, so this is what I have here. This is already a 3D. Okay, you know that, right? This is already a 3D, so you can easily screenshot this or save this as image open the image later and screenshot. However, let me change this background to a white color. If you're working on MS Word, which is always white, yeah, if you save this, you're having a black background. You can start it to automatically come out with the blue background, right? So what do? I'll go to display, I'll go to background, and I'll save it as white. I'll change it as white. Alright? Okay.
So please can you do that?
You got how we do. Just go to display, go to background, go to what white. Right? Then I'll click on white. And then this will appear. Okay? So this is what we have. Okay. I think at this point, okay. Oh, well, let's still continue. So this is what we have. This is the light on inside. So I was telling you that this is already a 2D, a 3D view, right? But this is a ribbon view, okay? Or rather, yeah, a ribbon view of our protein library. Okay, so there's another little interesting uh, kind of 3D that I usually use for my interactions. Okay, aside this, okay, I usually find a better way to distinguish this pocket from the rest of the protein. Are you getting it? I find a better way to distinguish the pocket from the rest of the protein and color them differently as well, so that even a layman can easily do what? Understand it. Alright, so what do? I will go to all. Under this, you will see A is for action, S is show, H is height, just opposite of show. Then L is to label, and then C is what? Is color. Okay, C is color. The same thing you discover you have it for all the things you have. Alright, so what do? I'll go to all. All means everything is here. Okay, so I'll go to A here, and then I'll click on preset. Alright, just hold your mouse on preset. This will appear. Then I'll go to ligand site. Remember, I want to distinguish the pocket, right, from the rest of the protein. So I'll go to ligand site, and then I'll go to canteen. We got to this extent, right? Okay, so I'll click on canteen. If I click on canteen, something like this will show. Okay. Um, One of the use of mouse is this is to increase the visibility. Can you see that this is zooming? Some of the contrast is fading.
Yes.
Can you get that? So, you people will permit me to.
You cannot use your hand.
No, you can't use your hand. You can only zoom. If you zoom this to visible now, zoom to visible, you can see that it will still come out though. Okay, it will still come out, but the the, the zoom level will reduce. Are you getting it? But zooming to visible will make you help you work, you know, without using mouse. Right? But if you need them to have a closer look and then maybe snap that close look, you can use zoom to visible to do that. Is that alright? So if you start working more with this, you need a mouse. It doesn't mean your mouse is not working on the keyboard. Okay, so this is what I have. I have already located the active site, and if you look closely, you will discover that there is something that have happened in that pocket. Some amino acid has been opened up in that pocket. I don't know if you can get that. You can see some groups, see them here. They have already shown up, unlike here.
Yes.
Okay, let me hide this one I'm talking about. So what do I do next? I'll go to my protein. This is the protein, right? This level is for the protein. Can you see that? Okay, so I will come to the hide. Okay, and then I will hide the cartoon. Remember, I clicked on cartoon before, right? So I'll hide the cartoon. Look at it. If I hide the cartoon, only the amino acid within that pocket will do what? Will show, right? So what do I do? The same reason. Okay, let me zoom to selection. Okay, so that this can just come. However, I can't really regulate the extent of the zoom because I'm working. Alright, so this is what I have. The next thing I do is to select everything here. So let me just zoom back to this again. Okay, I'll need to select all the groups here I have inside here. Now, alright, these are amino acids, two of them, and this is our ligand. You can see it's making interaction. This is the arginine actually. It's making interaction with. I could actually label this. Okay, if I label the residue, you discover that is what is actually the pocket. So, but I can hide this. Hide the lines. The label that is okay. Okay, I can clear the okay. I can also
Make sure
hide.
that nothing.
I hid it before I cleared it. Okay, that one will not be a problem. So let me just clear that. Okay, it's still there. Alright. So what do I do? I will need to select each and every one of them. Okay. So you can select it one after the other. However, when you click outside, they will disappear. You will now come and start highlighting. But if you are highlighting and you are holding back down the shift button, even if you click outside, it won't disappear. So also you could hold down the shift button and double click and highlight everything at once. Yes. Yeah, you hold down the shift button, double click and drag. Or you right click, double click is same as holding down this left button as if you want to highlight something. Okay, so you hold down the shift key, highlight all, and then come and click the ligand. Come and tap on the ligand to highlight just the ligand. Remember, it's the group you wanted to highlight, not the ligand.
Sir, you need to start this. Sorry. I understand this one, but from beginning till now, there is like a gap in between. You understand?
Okay,
We can do it tomorrow.
no, we cannot do it tomorrow. We have to finish this one now. Except you want us to cut down on some things. It's better we learn the learning and then go and keep practice. Isn't it? Than learning short. Good. You will get the record later to look through. Okay. Did you get up to this place?
Before this is.
Okay, before this
Yeah,
place.
start from.
Okay, okay, okay. Okay. Let's see, let's see, let's see, let's see. See. Did you get? Okay, don't worry. Okay. I said if you load the protein like this, assuming this is our complex one, then you go to all, okay, which is the first one here. Go to the all, go to the action in all, then go to presets in all. Under the
Go
action,
to action.
yes, which is the A. You go to A, click on A, then click on preset under A. Then click on ligand site. Then click on cartoon. Click on our phone. Eh? You know, with it, okay. I just pray you will not tell me that you are lost again.
So, what we had, like, what are we doing?
We want to locate the pocket, okay, where the ligand is bound so that we can distinguish it from the rest of the protein. Some people don't do that, but I'm just showing people that you could actually do that. Alright, so you click on cartoon, the protein pocket will appear, including the amino acids that are interacting with that particular pocket. Unlike outside here. Is that right? So what do I do? I'll simply zoom to visible so that I can see that very well. So after this, the next thing you do is to hide the rest of the protein and focus on just the inside of the protein, that pocket. Alright?
Just for like outside and then cartoon, click on the cartoon and it will be like
And you want to hide the all the
Yes, you want to hide the rest. So you go to the protein. This is the protein, the clean protein. Then you go to the H under that line. The H signifies hide. Alright? So you click on the H and then you see a pop-up option. You are going to say cartoon. You are hiding the cartoon you just added now. So I'll click on hide cartoon and then the cartoon will be hide. I will be hidden. So this is the you are still seeing the cartoon. The cartoon will just have okay, so this is what I have now. I want to select all these. As I select them, another option will appear here, trying to show me that. For instance, if I click on this, do you see that something came out here? Select option came, meaning you have selected something here. So what do? I will need to select all. I told us you can do this one once. Okay, but it will take time. So what do? You shift, hold down your shift button, double click, and then highlight everything. Shift, hold down the shift, and then you can double click. The same double click is the same as holding down this button. You understand? Okay, so what do? I'll simply hold down the shift button. Okay, so this one, but the ligand as well is highlighted, right? So you have to highlight the ligand. No, anywhere you are typing, I'm saying that it's either you double click or you pull down this. Okay, so just like in the MS Word, you want to highlight, you double click or you pull down this. So I will have to highlight the ligand.
How do you know where the tiger is?
Of course, I know. I can click here. This is ligand. If I click here, the ligand will come up. Yes. If I click here, the ligand will still go. But I can, yes, you just know
you need to color it
the ligand.
at least to
Don't worry, we'll still get to that. So I'll highlight that. And then after I'm highlighting it, I need to rename this selection so that it will become steady there. If you do rename it, if you click on any other thing, it will become the next selection. So what do I do? I'll go to A. Under the select, I'll go to A. A is action. The action I want to take is to rename. So I'll click on rename. Alright. Then I'll hit on rename. If you hit on it, this thing will appear here. Okay. This is then rename means to give that selection a different name, right? So I will rename this as active site. Active site. Alright. Anything you save it as it will answer. Okay. So I can now hit on my what? My enter. If I hit on enter, the active site, that select have turned to active site. So even if I click outside, it's already there. Are you seeing that? So, okay. So it's already there. Is that fine? Remember, I just hit the cartoon. I did not delete it, right? So if I show it, it will still appear, right? So are you lost? Okay, so I will go to the same protein and now I will show. But this time I don't want to show it in cartoon. I want to show it in surface view. Okay, I prefer surface view to cartoon view. Surface view will expose the pocket well how it is on the cartoon. Do you understand? So I'll hit on what? Show under the protein. then I'll hit on surface. If I click on surface, this is what I will have. Okay, yeah. More reasons why you need a mouse. So you can see the protein. Can you see that line? Can you see that? So what do? I'll zoom this to this area. And then can you see it has come? Look at the ligand inside there. However, it's still not visible. The layman might not understand this, right? So what do? I will color the entire protein. Let's say I color it blue.
So still go back to that protein.
Yeah, you still go back. Anything you want to do with respect to the protein, you go to the line of that protein. So I just color the entire protein blue. This time I'll color the ligand, the pocket, right? With another color, say white. A color that will make it stand out.
You tap on the pocket.
Yes. You don't need to tap it, it's already here. So you just go to the color under that same line and change the color to white. Under gray, gray is under black. It's already here. That is this. We renamed it as active. We renamed it as active. If I highlight on it, can you see that? So that's the active site. So you can see that portion is already extinguished, right? So I can now color the ligand now. At this point, I can click on the ligand inside here. So if I tap on it, it will get highlighted. That one I don't need to save. If you like, you can still save ligand. For me, I don't need to. So once I just click on it to highlight, I can change it to say red. So that I can. Okay, what color do you see? Okay, okay, we can change it to red. Can you see that? Can you see that? So if, for instance, you just wanted to view this or zoom this further, let me see if this can zoom active selection. Okay, you can see as it's zooming it's making this new some of. But if you're working with mouse, let me just show us what I mean. I did not, I still gave up again. Okay, so this is the mouse, right? Okay, you like laugh at my mouse.
Yes, my yes.
Okay, alright. So this is what we have, right? So if I look at this top, this thing, the screen, okay, the scroll button. Discover that before this was not complete, some of this were empty, right? This will help me to not just get it covered, but these light places will become deep, alright? So, right now, so this will make it deep, alright? Then, if I click on this and move it, I can, are you getting that? I can reduce the zoom. Okay, so I will remove, so group self. Okay, something like this. It's from my book. Okay, so this is what I have. This is gold and fine. Can you see that? However, because I'm still working on one, remember all the confirmation are still there, right? So you can see that, but this is number one. Okay, this is two, this is three. And that is how that is. Alright? So that is actually the pocket. So after this you can save, this as your what? Um you can export this as image. Okay? This is now a picture, right?
Yes.
You can export it as image. The image could be a PNG file. Okay? This can be a what? PNG file. Is that alright? So I'll click on that image. It will ask me if I want to save this. I'll say yes. So I'll click on save. It will still take me to this. So I usually title this 3D view. It's screenshotting this. If you screenshot, you are just screenshotting. Copy some, just screenshot really have. It's just a kind of a picture. But until you save it, it doesn't have an extension, right? So this is it. Yes, you can see when you open the saved one, you can still screenshot from the saved one. You understand? But okay, let me not tell you. But actually, if I'm working, I already know what I'm doing, so I don't need to stress myself saving. But you might make mistake, and if you didn't save, you will not be able to locate it. So I don't encourage you not to save before screenshotting. So this is it. So I can now, if I'm working with my destiny, I can now screenshot this. Okay. And then, more importantly, while screenshotting this, you don't
Get
this Euroliga, yeah, this Euroliga people will always keep worrying if you have the
That will give us shift.
shift window and X.
or you can just type sniping to
And
space
X.
and
Yes, or sniping tool. Yes. If you type your sniping tool, it will appear as well. This is the sniping tool.
Click it.
Yes. Yeah, you can use it to screenshot. Okay, so I've screenshotted that. I can easily come here and post it. Alright. So this is what I have. This is my 2D, this is my 3D. Can you see that? Then lastly and more importantly, when you're working with more than one ligand, mhm, this your protein is certainly going to remain like this. If you turn this protein like this, and snap or save the next one, the two picture will look different. And na you will explain am later because you must position it this way. So what you need to do, what you'll be loading here is simply your ligand, not your.
So this is what you put in your work.
Yes, this will go in your work. So this protein will remain here. What you'll be deleting here is the ligand. You can delete ligand here. There is another. Look at that thing I was saying before. I can now move down because I have notes here. Okay, this system is a mini one, so it compresses on that. So I can delete object here. If I delete this object will go away. So I can insert the next ligand here, and it will just, if it's the same protein, sometimes you can dock up to 10, 20 ligands in this one protein. So you don't need to keep deleting the protein, bringing in another one, and starting this process again of coloring and all that. Are you getting that? When I was doing it, then I was repeating the whole thing. At the end, you might not even get exactly this form. And when you post this, people that don't understand it very well, you will be the one that explain to them that this is the same protein, this is the same, and it's a very easy way to catch people from seeing the work. And somebody might have something like this, and then the protein is somewhere here. The protein is somewhere here, okay, which automatically tell you is a different pocket. Another person might do, and then you have a protein here. The person will just tell you it's a 3D and all that. But when you do it this way, okay, yeah, it tends to represent the same protein because the shape, everything is the same. Even a layman will understand that Omodi is actually the same. The person will look at here, look at this thing, look at this one, look at the other one, everything is the same. Oh, that is how I personally do it to come out with it.
So how do you know fix another ligand?
So you just go to open again.
So
Okay. Since you docked those ligand against the same protein, if you enter the inside the ligand and the ligand was properly docked, it will appear.
okay.
It's as simple as that. If I go, for instance, now I only have one here, but if I go to that place again and click, if it's in another folder, if I click on this ligand all again, it will simply insert it. Then I can now zoom back with my mouse. You can first of all now zoom back. Okay, yes, and now save it. This thing now, the upper this will make it the color become very
you cannot do the full.
no, you cannot do this. You can only zoom in and out.
So you
With
don't have
the normal this thing. Is that alright? So at this point, you can now ask your question. This is where we will end for today. We've been able to carry out the docking, this time site-specific docking, and we're able to see the docking results, interpret the 2D diagram, investigate the 2D diagrams of the docked result, and as well the word the 3D diagram of the third result. I think that is okay for today. The rest will continue in the next